Okay. But note that 10 megabits per second, 100 megabits per second, both require sending at least 64 bytes or 512 bits. Okay. So what if the frame or the data within the frame is only 10 bits? You got to pad it. Right. You got to pad it so you can have at least 64 bytes. Now, what's the minimum bits required to send 1 gig or a frame at 1 gig? It's right there, 4,096 bits, right? Okay. Well, why do we increase the slot size when we increase the speed? Why do we increase the slot size? Okay. Need more mosquitoes? Okay. Well, look at it this way. Is it easier to see a golf ball traveling at 2,000 miles per hour in comparison to a soccer ball? It's easier to see a soccer ball, right? Yeah, when objects are traveling faster, if you want to detect them, you need to make them larger. Okay. Right. Okay. Now note how fast a bit is traveling within the 1 gig bandwidth. 1 nanosecond. That's really moving, right? Okay. Right. Now we just can't send frames in a serial manner without having some type of space in between them, right? Why is that the case? Yeah, you got to have, you know, a timeout period so the other devices can sense that the media is cleared so they can communicate or use the media, right? Okay. Also, the receiving device needs to know the beginning and the ending of a particular frame, right? Notice within the Ethernet protocol, there's a 96-bit time interframe spacing. So if A through E segments or sections consist of 1 frame, okay, E denotes the end of the frame, then there's an interframe spacing, and that spacing is going to be how many bits? 96 bits, right? If we're talking about 10 megabits per second, then we know this slot time, all 5 of these sections will in total equal how many bytes at a minimum? 64 or 512 bits. Okay. Notice as we increase the speed, the interframe spacing time decreases. Yeah, a device that's operating at 10 gigabits per second is very sensitive and responsive. It has to be in order to denote or to see the distinction between frames, especially if we're talking about this time period there. Okay. Go through this interactive at your leisure, as well as this one. Yeah, go through this activity at your leisure. All right. Okay, here we have two collision domains. Right. Let's imagine that we're talking about the switch is operating at 100 megabits per second. There are 7 PCs on this side of the switch and 8 on this side. So on this side, you basically need to divide 100 megabits by 8. Okay? And that'll tell you what portion of the 100 megabits is reasonably allotted to each of these devices. And on the other side, you have to do the same thing, but it'll be 100 megabits divided by 7. Now, why is this a collision domain? Because if a collision occurs between this device and that device, all devices will be aware of the collision because it's a broadcast. You know, hubs broadcast everything, including collisions, right? All right, let's make a comparison to the switch. You see each PC is associated with a different broadcast domain. Okay. Now, with that said, each link is operating at 100 megabits per second. So each PC is literally getting 100 megabits per second. Each PC is not sharing it with some other PC. Okay? Yeah. Okay, go through this activity at your leisure. From hubs to switches, we did that earlier in the packet tracer activity that I somewhat embellished beyond the instructions. Okay, this activity gets into how a switch learns MAC addresses, and we talked about that, but still go through this particular activity at your leisure. More switch learning MAC addresses. All right, let's take a look at this particular activity. Let's see whether or not we can answer these questions correctly. Okay, here is a frame. We see that the destination is FF and the source is OA. Here's a switch, and we see MAC addresses that are associated with switch ports. However, when we look in the actual switch operating system, the MAC address table, we see that the switch has learned OA, and it's associated with port 1. There's nothing associated with port 2, which is correct. 0B is associated with 3. Yeah, that's correct. Okay, has not learned 0C, right? Which should be associated with port 5. It's learned 0D. It's learned 0E, but it has not learned 0F, right? Okay, so let's answer the first question. Where will the switch fall with the frame? So we need to check all the ports. Okay.
Oh, wait a minute. Maybe one that something's connected to the active port status.
Okay, so we should not check. We shouldn't check FA1. We should not. We should. Okay, but there's something else.
So then 2, 4, 6.
Oh, you're right. We definitely need to uncheck the source.
And then inactive port.
What about FA3?
Check it. But, yeah.
Well, somebody's thinking that it. It's FF. So we can assume that FF is the broadcast, right? All right. So if it's the broadcast, it's going to go to every port. Except, right, it will send to every port except the port it received the signal. All right. It should not send it to the unactive ports. The switch is going to be aware that the port is down. So we will check that. Technically, we should uncheck the unused ports. All right. Okay, question 2. When the switch forwards a frame, which statements like S are true? Well, in this instance, it already knows the source, right? It knows which port is associated with the source, right? Okay. What about this one? Yeah, to all active ports. It's not a unicast, which means it's directed to one particular end device. Right, it could flood it if it didn't know the destination, right? Okay. All right, does this look good? All right, should we go forward? Chris, something's wrong? Corey, should we go forward? Oh, let's check it out. Okay, switch S is source. It's already in the table. Okay, let's check it out. Correct. Wow, good job. Good job. Good job. Let's go to the next one. That's a tricky one. And this is exactly the way the Cisco certifications are. You really have to know the facts and then be able to analyze the situation while depending on those facts. Analyzing, of course, in a logical manner. All right, so new practice problem. Okay, destination is 0C, source is 0F. Let's look in the table. 0C is there, right? 0F. What about 0F? 0F is in the table, right? Okay, so where will the switch forward the frame? It'll forward it. It's going to receive it